Hello everyone, we are from Center for Computer and Communication Technology and we are Electronics and Communication Department doing diploma at CCCT. Today we are going to make the project based on agriculture monitoring system using Raspberry Pi. And before going to the project, I would like to show you the block diagram of my projects, and here you see the block diagram. This is a block diagram of our projects, and here you see the middle one. This is the Raspberry Pi 3B model B plus, and I have connected the many sensors over here like DHT11 temperature sensor, humidity sensor, PIR sensor, moisture sensor, smoke sensor, and also a motor. So as you are seeing that in these projects there are connecting the many sensors, but all these sensor data are continuously uploading at the ThingSpeak platform, which is used for the Matchbox account, and from ThingSpeak we can access all the data as a public or a private. So we are giving the power supply of 5 volts to the Raspberry Pi from the laptop, as I am not supposed to be use the power banks. Then I am using the power bank as a laptop, and our topic is IoT projects based on agriculture monitoring system using Raspberry Pi. So after giving the short description of block diagram, and I am going to show you the connection diagram of our projects. And firstly, I have connected the PIR sensor over here, you are seeing, and there is also a Pi camera, but the Pi camera is not available now, and I am, instead of using Pi camera, I am using a small LED over here, white LED. And next there is a humidity and temperature sensor, which measure the humidity and temperature of the field. And this PIR sensor is used as the trespassing in the agriculture fields, whether it can alert from the wild animal, basically wild animal. And I have connected the moisture sensor. As you see there, this is the moisture sensor L69, and here it is on. You are seeing this, it is on. And next I have used the smoke sensor. As you see there, this is also on, and it will detect the smoke and alert from the fire, and this will measure the moisture content in the soil. And for this I have used the small plants over here, you are seeing that. So I want to put it here. Then next we have the main programming device, that is Raspberry Pi 3 Model B. As you see this, there are many ports. HDMI cables are used in these ports. Then I don't have an HDMI cable, that's why I am creating my mobile hotspots to run this device, and I am giving the power supply from here. As you see, this is the display. If I am using a display as my laptop, then it is not connected, and as here is the camera. If I am doing this Pi camera with PIR sensor, so I have to connect this Pi camera instead of this LED. I have to connect this Pi camera over here. Okay, these are all the sensors integrated to the Raspberry Pi Model B. Then I have used the 32 GB of external memory for storage purpose. And as you see there, this is the solenoid valve, and here I have made a small tank, and this is the solenoid valve, and it's work through the 230 volts AC. And for this we have used the relay module, so it can be automatically switch on switch off through the relay module and IR sensor. So after showing the circuit description and block description of our project, and secondly I am going to show you the working of our projects, how it can work. So let's move towards the code and programming terminal. So I have shown the connections of DHT11 sensors, and we have to run the code, and we are going to run the code. And for the code I have to write the command. Firstly I have shown the code. Okay, let's get it. So I'm going to showing the code. Sudo gedit sudo gedit dht11 .py. Sorry, .py. Oh, there is spelling mistake. Sudo gedit dht11 .py. Okay, then we are seeing the codes over here. For this code I have to save this code firstly, then I have to run this code by writing the instructions python dht11.py. So the temperature and humidity data are showing. Okay, we are seeing the 360, and we are generating the few minutes of delay. Okay, next we are seeing the 370. For the temperature and humidity. And next we have PIR sensor. So I am very much sorry that there is some mistake in our code, and so I am going to show you the output of our PIR sensor. And I have used it's nearby the laptop, so we have to get the motion detected outputs from the PIR sensor. So I am going to run this code. So as you are seeing this, it can detect the motion was detected. Then was detected. Then I am going to take off these sensors from here, and you see it can show the motion is not detected. So next I am going to run the moisture sensors code, and so I have to enter into the code. Moisture enter. So sudo gedit moisture.py, sudo gedit moisture.py. So here you see that it is the code of moisture sensors, and I am going to the 20 selecting delay. So I have to going to save it, and I am creating a channel on channel number 21 as a GPIF input. So I am going to run this code. Likewise, GPIF sensor, I am going to run this code as a moisture.py. So there is some no moisture content, as I have firstly I have taken all the moisture sensors, secondly I had put it into the plant, so it is showing the no moisture content. Firstly I have this is outside the plant and this is outside the water. Then secondly I have put it to the water, or put it into the plants, and next it is showing the moisture content. So it's running here, and next I am going to show you smoke detector. So for the smoke detector I have to enter in smoke detector sensor. So I have written a smoke. I am entering into these sensors, and I have entered into the code sudo gedit smoke.py. So as you see, this is the code code for the smoke detector sensor. If the smoke is nearby this sensor, and it will print the sensor detected action. The sensor is detected the action not detected. If there is no smoke around it, it sends showing the smoke not detected. Okay. Then I am going to show this code or run this code. So likewise, moisture sensor, I am going to run this code as Python smoke.py. So I am entering. So action no needed, sensor detected action no needed. And yet I am not the sensor is not getting the smoke around it, so it is showing the action not needed. So any action can be not needed to the sensor, and the sensor is very executing the output power. So this is the coding sections from the Raspberry Pi board, and next I am going to show you this all data to the ThinkSpeed platform. So for this I am going to show you all the sensor data to the ThinkSpeed platform. So next I am going to show you the PIR sensor data to the ThinkSpeed, and as the previous I have shown the circuit diagram of this PIR sensor, and here you see the PIR sensor data to the ThinkSpeed platform, and it is showing the value of the PIR sensor. It is decreasing in a first 0, then 0.51, and I have created the channel to the field 1, and it accessing to the public view, and in the upward, if we want to do the MATLAB analysis, there is the MATLAB visualization and MATLAB analysis, and in this platform we are able to access the app also if we want to access the data to the mobile phone. So for this purpose we have to access the data to the mobile phone. We have to use this app sections. In app section you see that the thing with time control React. From this React we are able to show this data to the cell phone, but without the some components it's not be possible. So that's till here we have done this project, and we have access all this data to the platform. And next I am going to show the DHT11 sensor data to the platform. So next we are going to the sensor data to the ThinkSpeed platform. For sensor DHT11 data I am going to be showing you the details how we have to push the data to the ThinkSpeed, how we can create, how we can give the API keys. DHT11 sensor data. In this I have to show all the details of the ThinkSpeed platform. So for the DHT11 data, as I have shown the PIR sensor data on the ThinkSpeed platform, and next I am going to show the DHT11 data on the ThinkSpeed platform. So here I have created a channel as Raspberry Pi data, and this is my Raspberry Pi ThinkSpeed platform, and as you are seeing here, channel, app, supports. This new channel I have to create the new channel from here, and for this I am opening this Raspberry Pi data. So I have opened it. As you are seeing that there is no any data on this temperature and humidity on this channel, so on this field. So for this I have to go to the API keys over here, and I have to write the data. There are two options: write API keys and read API keys. So I have to copy this write API keys from this platform. So I have copied it, and I have to paste it in our here API keys over here. I'm going to paste it. So I have paste it, and I'm going to run this code. So next I'm going to run this code. It's getting running. It's showing 1 or everything else, and next I am going to the here my channel. So it is showing that there it is showing the data. Temperature is showing 25, and humidity is showing 87. Next it is increasing, Here you see the data. The code is running out and the data are showing, as you are seeing that 1, 0, 2, and the data are converting into the data are converting into parent. So next, it's getting increasing. Oh, here you see the graph is going like this. So from this platform, we generally access the data from anywhere, and as a public view, as a private way, as I wish to put it as a private view, then no one can see my data. So I am going to showing it to the public view. So here you are seeing that the humidity data are changing. So today there will be raining, so it's little bit temperature is low. Then here you're seeing the temperature is stable, but the humidity is going up and down. Here you see this. I am going to see, okay, 25, 25, as the temperature is constant, but humidity 87, 87, and it's going to 95. Here you see, then it's getting down 89, and again 87. Again you see the data are changing here. So we are planning to access the data through the mobile phone, but it's not possible. That's due to some failure or due to this lockdown problem. We are unable to offer some component. Then we are made our projects till here. So here you are seeing the data are changing, and as well you are seeing here also, here is the data for the PI sensor, and for these 3 sensors I have collected its data on the TeamSpeak platform. So I have shown all my circuit operations and working and programming as well. And lastly, I am going to say that due to some failure of our component, and we are unable to proceed further, so to some working of our projects. So as we do not have the Pi camera as a model over there, as instead of it I am using the LEDs. So here this is the pump. So pump is not directly it's working, but we have to made it automatically by using the relay model with the air sensor. We have get the air sensor, but we do not have the relay model, so I have connected it directly with this tank. And others it is good and it is working also. And for this I have used 3 sensor data to the TeamSpeak platform. As previous you have seen this, firstly PI sensor data, secondly smoke sensor, secondly pH level as well, temperature and humidity data. These 3 sensor data I have been showing you in the previous. So by saying this, lastly I would like to conclude my project and hope you all enjoy it. And in the guidance of our man Terry Lafontaine, we have completed this project's work, and we are going to thank her for its suitable cooperations. And this is our final year project. So hope you guys enjoy it. So thank you all.